how do we know whether a compound or whether a solution is acidic or basic? Well, we can do this in multiple ways, but the most helpful and common way is by using the pH scale. The pH scale is basically a scale that goes from 0 to 14, and it tells you that this region, for example, this region is acidic and this region is basic. And wherever that solution falls, right? If let's say it's 2, that would be in the acidic range, versus 9, that would be in the basic range. So it's used to indicate the acidity of a solution and has values that range from 0 to 14. So in this case, the scale goes, let me actually draw it here for you. So it goes from 0 to 14, right in the middle at 7. This region right here is the acidic region. This region right here from 7 to 14, or above 7 to 14, is the basic region. Sometimes it's called the alkaline region. And as we see here indicated, you should know that the pH comes from the word pH, or that acronym stands for the power of hydrogen. And we're going to learn about the equation in a second. But before we go there, here are some common items that are either acidic or basic. So gastric juice, stomach acid, lemon juice is about 2.2, vinegar is about 2.8, carbonated beverages about 3, you have coffee at 5, you have bread at 5.5, potatoes. And then in the basic region, so water is at 7, so it's neutral. Blood plasma is about 7.4. So actually blood is what we call a buffer. And you have bile, you have detergents, you have seawater, it's slightly basic. You have ammonia, bleach is at 12. How do we calculate the pH of a solution? So the word, as I was indicating, the word, or the acronym pH stands for power, or the exponents, you can think of it. Let's make this a subscript so that I can look better. Okay, so you have the power of H, okay? So basically it's the negative logarithm of the hydronium ion concentration. So when you dissolve an acid, so we're going to call it HA, with water, water takes the extra proton that came from here, goes to water, and it becomes hydronium. So the pH is the negative log of H3O plus. So in your calculator, you should have the log function. And if you want to know more about logarithms, it is really about the exponents, right? It's and the powers in a number. So, but before we go there, we don't need to go there. We just need to use this key. So in your calculator, you should have the log function, and then you put a negative, and then whatever value is given for the concentration of hydronium ion, you put that in parentheses and you hit enter. So let's look at a question that helps us understand this calculation. So acetylsalicylic acid, also known as aspirin, was the first non-steroidal anti-inflammatory drug used to alleviate pain and fever. If a solution of aspirin has H3O plus, which is the concentration is 1.7 times 10 to the negative third, what is the pH of the solution? Okay, so what we need to do is we take the negative log. So in your calculator right now, hit negative log and then enter 1.7. And again, if you have the key EE, -3. So that is the equation that you will need to use. After plugging it in, you will get 2.7. Let's stop at the 6769. Now, when it comes to rounding these, you can round this. It's actually according to the decimal places. But we'll just, for now, just keep it at 2.8. So the pH would come out to be 2.8. So is this acidic or basic? It is acidic. Similarly, we have the POH, which is used now for the concentration of OH. So it's associated with the OH minus concentration of an aqueous solution. So now the equation is when you have the POH, you use the negative log of the concentration of OH minus. So you're going to plug in the same thing, except it's going to give you something called the POH scale, but we will learn how to use that in the next problem. So you go and again, you plug in negative log of, put 2.88 EE -6. Okay, so if you do that, that will give you 5.54. Now, you cannot say if it's acidic or basic by looking at the POH. You'd have to actually think about it more conceptually, but probably don't need to do that. We have an easier way. You need to remember that when you add the pH to the POH, they should always equal 14. And 14, is where you actually have the neutral. So anytime you have to determine whether it's acidic or basic, all you have to do is subtract that number from 14. So in this case, let's look at this question. Calculate the POH of a solution if the pH is 4.5. So we're going to write the equation down. pH plus POH equals 14. We're given the pH, so that would be 4.5. So I'm going to subtract 4.5 from each side. And that gives me a POH value of 9.5. Now, since you're given the pH at 4.5, that's acidic, because again, we're going with the pH scale. So let's go back to this one right here to determine whether it's actually acidic or basic. So again, we will use the same equation, pH plus POH equals 14. We will plug in the POH value because that's the POH. We will subtract 5.54 from each side. So we'll take 14 minus 5.54, and that gives us a pH value of 8.46. So 8.46 is basic.